Assalamu alaikum wa rahmatullahi wa barakatuh. This is the fourth video of Chapter 8, Electromagnetic Induction. At the end of this video, you should be able to apply Faraday's law and Ohm's law across a coil. First, let's remember some of the concepts of the previous video. 1. Electromagnetic induction is the induction of an electromotive force E in a conductor when it is placed in a variable magnetic flux. 2. The variation of the magnetic flux is obtained either by the variation of B or by the variation of S or by the variation of the angle formed between B vector and N vector. 3. According to Lenz's law, the induced magnetic field BI opposes the variation of the inducing magnetic field B. 4. According to Lenz's law, the electromagnetic force F exerted on the rod in the case of the variation of S always opposes its velocity V. Laws of electromagnetic induction. The laws of electromagnetic induction are Lenz's law, Faraday's law, and Ohm's law. Faraday's law. The induced electromotive force E at any instant is equal to the opposite of the derivative with respect to the time of the magnetic flux crossing the circuit, where E equal minus d phi over dt. Phi in Weber, T in second, and E in volt, where E is an algebraic quantity, so it can take a positive value or a negative value. Ohm's law. Ohm's law states that the current through a conductor is proportional to the voltage across the conductor. So I equal E over R total. I in ampere, E in volt, and R total is the total resistance in the circuit in ohms. And I is an algebraic quantity, so it can also take a positive or a negative value like E. Signs of E and I. If phi increases, so d phi over dt is greater than 0, then E is less than 0. If phi decreases, so d phi over dt is less than 0, then E is greater than 0. If E is greater than 0, I flows in the induced circuit in the chosen positive sense. If E less than 0, I flows in the induced circuit opposite to the chosen positive sense. In the phenomenon of electromagnetic induction, when the coil acts as generator, in the majority of cases, then E dot I always is greater than 0. Application 4. The magnetic flux in an induced circuit varies as a function of time according to the equation phi equal 10t plus 2 in SI units. Find the induced electromotive force in the circuit. According to Faraday's law, E equal minus d phi over dt, so it's equal to minus 10 volt. Application 5. The magnetic flux in a circuit varies from 0.2 Weber to 1 Weber during 50 milliseconds. Calculate the average induced electromotive force which appears in the coil. E average equal minus delta phi over delta t equal 1 minus 0.2 over 50 times 10 to the power minus 3 seconds multiplied by minus, so the answer is minus 16 volt. Variation of angle formed between B vector and N vector. Consider a coil of N turns that rotates about a vertical axis delta in a uniform magnetic field B as shown in the figure. The coil rotates in a constant angular velocity theta prime equal omega equal constant. Expression of the magnetic flux phi. Phi equal NBS cosine theta. During the rotation of the coil with a constant angular velocity omega, theta varies. So the expression of theta with respect to time is theta prime t plus theta 0 equal omega t plus theta 0. And the expression of the magnetic flux phi becomes equal to NBS cosine omega t plus theta 0. Expression of the induced electromotive force E. E equal minus d phi over dt equal plus NBS omega sine omega t plus theta 0, where the value of NBS omega represent the maximum value of the electromotive force, so the expression becomes E equal EM Emax sine omega t plus theta 0, which represent a sinusoidal alternating voltage, and the adjacent graph represent the expression where theta 0 is equal to 0. Expression of the induced current I. According to Ohm's law, I equal E over R total equal NBS omega sine omega t plus theta 0 over R total, where NBS omega over R total represent the maximum value of I, and the expression of I becomes I equal Im I max sine omega t plus theta 0. The adjacent graph represents the expression of alternating sinusoidal current where theta 0 is equal to 0. Applying Ohm's law on the induced circuit. The adjacent figure is a diagram of the equivalent generator of a coil. The coil is oriented positively from A to B, so UAB equal Ri minus E, where R is the internal resistance of the coil or of the equivalent generator, and UBA equal minus Ri minus E, so it is equal to E minus Ri. Note, for the previous expression, I and E are substituted in algebraic values, so I and E may take a positive values or a negative values, and the expression of UAB is not changed if the direction of the current is reversed. It is independent of the direction of the current, and it depends only on the positive direction that is chosen in the circuit. I equal to 0 if the coil circuit is open, then UAB is equal to minus E. Application 6. A flat coil of resistance R equal 50 ohm is placed in series with a galvanometer of negligible resistance and oriented positively from C to D. The measured value of I and E at an instant t are respectively 4 times 10 to the power minus 3 ampere and 2.2 volt. Suppose that the induced current traverses the coil from D to C. Calculate the potential difference UCD. UCD equal IR minus E across the coil along the positive sense. And since I is opposite to the positive sense, we substitute I in its negative value. And since E and I have the same signs, E is also substituted in negative value. The expression of UCD becomes equal to minus 4 times 10 to the power minus 3 multiplied by R, the internal resistance of the coil, which is equal to 50, minus 2.2 equal 2 volt. Deduce the value of the resistance of resistor R. According to Ohm's law, U equal Ri, but UCD equal minus Ri. Since UCD is across the resistor opposite to the positive sense, then R equal minus UCD over I equal minus 2 over minus 4 times 10 to the power minus 3, since I is opposite to the positive sense. So the value of R is equal to 500 ohm. 3. Draw the equivalent generator to the coil between the points C and D. The adjacent figure represents the equivalent generator of the coil, where the current I leaves the generator from the pole C. Summary. 1. Laws of electromagnetic induction. Faraday's law states that E equal minus d phi over dt, where E in volt, phi in Weber, and T in seconds. And Ohm's law states that I equal E electromotive force over R total, where E dot I always is greater than 0. In the case where the coil rotates at a constant angular speed omega, theta equal omega t plus theta 0. Phi equal phi m cosine omega t plus theta 0. E equal em cosine omega t plus theta 0. And I equal im sine omega t plus theta 0. 3. According to Ohm's law, the voltage across an equivalent generator of terminals A and B is UBA equal Ri minus E. Positive direction is from A to B in this example. 4. During the phenomenon of electromagnetic induction, the induced current may be 0 if the induced circuit is open or if it is closed at an infinite resistance. This is the end of this part. Study well and thank you for your attention.